All right, so questions. How's everything going?
Okay so far.
Okay so far, good. All right, let me talk about ODPs. A few things I've been observing. So first thing, when you want to assess, here's the command: assess executable source. 2 arguments. This is the program that actually runs, that does the thing the assignment says it should do. This is the thing that contains the source code. So if you're assessing a script, these are the same. It's goofy, I know. Right, just assess script. If you're doing a C program, right, GCC-O, whatever you decide to call it, main.o, and then assess executable program, sorry, that's main.c, and then source file. Right? It has no way of knowing if you're doing this correctly or not. It's going to take whatever this is and it's going to try to run that. Right? And it's going to take whatever this is and it's going to make sure it's a source file and it's going to copy it into the log file. So if you say assess main.c, it's going to try to run main.c and it's going to puke and it's going to say, is this what I should get for my output? No, and it gives you your 0 out of 10. Right? So it can't check this for you. Okay? So executable source file. Does that make sense? All right. Next thing I observed, so I scraped out the grades this morning and uploaded those. At least half the class is not getting 100% on these, okay? And grade-wise, that's not a big deal. The ODPs are a small part of your grade. But outcome-wise, that's huge, right? Everybody needs to be getting 100% on every ODP. That's your goal, okay? If you're not getting 100%, please don't just say, well, I got 75 and that's good enough because I've got enough other grades that'll pull it up, right? The goal of these daily assignments is to make sure that you completely understand whatever concept this assignment is pushing before the next class starts, because the next class we're going to build on that. So if you're not sure what it's asking you to do, send me an email, ask in class, post something on the discussions, okay? If you're writing your code and you're pretty sure it's doing the right thing, but it's not assessing properly, right? Ask in class, send me an email, post in the discussions. Again, if you decide to send me an email, don't do a screenshot, don't just say my code is not working, right? Show me the contents of your code, show me the assess session, show me where you typed in this, and show me what assess came out. You type the G command, what did it give you, all of that. Get all that on your putty window or whatever you're using, copy it with the mouse, paste it into an email as text, send that to me, okay? If you send a bunch of screenshots, I gotta wait till I can log in. That's usually the next day, okay? If you send me text, I can actually like look at it on my phone. And let's figure out, right, what the issue is. If your code is not compiling, so that you can't assess it, right? That's a separate issue, okay? If your code is not compiling on these, you really want to figure out why, and you want to nail that down. And not by trial and error, and not by, asking a friend, how did you get this to compile? Oh, get rid of that comma over there. Okay, fine, right? You want to make sure that you can do this. Okay, that's the whole point of these things. The grade is a tiny little piece of the big picture. The goal is get you on track, keep you on track as we move forward. Does that make sense? All right, so let's look at 409. Assuming the big unknown. All right, so 409, it's just like 408. You run your program, you give it an argument, it prints off the square root of that argument. Okay, and I'll show you 408 code in a minute. But you're also doing error checking now. Okay, 408, you could just say 408 space 25 space hello, my name's Nick, right? And it would take that 25, print the square root. So here you want to make sure you have exactly one argument, no more, no fewer. If you don't have exactly one argument, you print out the word ERR, new line, and you exit. If you have exactly one argument, but it's not a valid number, meaning you can't scan it with %LF, you print out invalid, INV, new line, and you exit. If you have one argument and it's a double precision number, but it's negative, you can't take the square root of that, you print out NEG, new line, and you exit. Okay? If none of those are true, if it's a valid argument, if there's exactly one argument and it's not negative, then you print the square root and you exit. ODP 408. So you got to check for 3 conditions and then print the square root if you're safe to do so. So here's my ODP 409. If I just say ODP 409, it gives me an error, right? If I say ODP 409 and I give it a number, it prints the square root. If I give it 2 arguments or more, it prints out error. If I give it a negative number, it prints out the word negative. If I give it something that's not a number, it prints out invalid. So it's got 4 different behaviors. And it doesn't say it here, but in the Canvas assignment for 409, it says there's a program, S1pub, that you can use to see what your program should do. Okay, so you can execute this /temp/S1pub, and this gives you more output, but ignore the things in parentheses, right? If you just run your program with no arguments, it should print ERR, right? The reason being that it detected an incorrect number of arguments. If you do this with a -4, it should print NEG because the argument's a negative number, and so on. So that repeats what I just said. But you can use that as kind of a test program. To compile, you got to use -LM because you've got a square root in here. Right, so same as 408. And then assess executable and source file. And you should get 10 out of 10 5 times. All right, so here's sample for ODP 408, the one that you already turned in, right? Usual stdio, include math so you can do the square root, standard main program setup, argc, argv, x is a double, could be any variable, scanf on that first argument, right, as a %LF, save the result in x. No error checking in 408, right? We're just assuming that argv1 is a double, and we're converting it into x, and then we take the square root, store that in y, and we print it out with a printf. Okay, lots of late night emails from people with extra spaces in here, spaces at the end, no new line at the end, things like that, right? Those all mess up the assessment because it's automated, right? So you gotta make sure you're keeping it happy. Yeah.
So in order to exit, we just put like return 0 or return 2? Or
Yeah, so you can say return 0 at the end. Yep. All right, does it make sense? So questions about how you're going to do 409? Yeah.
How would you assess the amount of arguments?
So write your main program like this. So this argc, this is your number of arguments. So if you just run your command with just the name of the command and no arguments on it, argc is actually equal to 1, which says all you typed in was the name of the command. If you say command with 1 argument, argc is actually equal to 2. It's counting the number of things on the command line, including the command itself. So if you say command argument 1, argument 2, then argc is actually equal to 3. And these arguments themselves are in the argv array. So the first argument is argv1, the second argument is argv2, and the command is argv0.
So could you put a if statement and say if argc is equal to 2, then run my code?
Mm-hmm. The other way to do that would be to say if argc is not equal to 2, print whatever the error message is and return. And then you don't have all of your code nested inside a big if statement.
Yeah.
But functionally exactly the same thing either way. This is a decent program to put together a flowchart on, right? If you have a good idea how to do this, a flowchart will take you a minute to write. Because there's no looping, it's just a few ifs. But the order in which you do these things is important. So here's something that we'll see sometimes. So this is pseudocode. I'm going to say, no, don't do this. So there's a first cut at some pseudocode that is not correct. So the first thing you're doing is converting argv1 to a double, and then you take the square root and store that in x, and then you check the number of arguments, and if it's wrong, print an error message. And if the argument is negative, print an error message. And the problem with this is, if you don't have an argument, there's a fair chance this is going to throw a seg fault.
I've seen that.
You've seen that?
Yes.
Okay. I've seen this too. Right? This argv bracket 1 is not meaningful unless argc is at least 2. Okay? So before you do this, you want to make sure that you can address argv bracket 1. So check argc first. And similarly, this can get you into trouble if x is negative. So check if x is negative before you try taking its square root. Right? It won't actually blow up. It'll give you something called not a number, NaN. Right? But if you were doing other things, right, that can get you into issues. So reason for I say flowchart, right, think about the order in which you want to do these things. Make sure that ordering makes sense. And this is, I don't know, in the past it's taken like weeks to get people to start thinking about the order of these things. And inevitably people's code is blowing up, and it's because they're checking for an error condition after they've already taken some action that causes that error condition to make their code blow up. So just think about the order, and like I say, think about just doing a quick flow chart if there's any issues there. All right, So other questions on that ODP?
What should we return if it gives an error?
You can return 0 in all cases. I don't use the return code. Yeah.
Just a random question not related to ODP. What if you want to return an integer or value to, say, something in a stored in a variable?
An integer?
What if you want to? What do you have a program now that has segments and some code
Mhm.
other than int main void?
Okay.
And you want to return a value from different programs.
So a value from a different function,
Yeah.
but you want to return it to the shell,
The original.
to bash? I don't know if exit will take an argument. It might. Because if you just say return, right, it goes back to main instead. So you may be able to say exit and give it an argument, but the proper way to do it would be to return to main, but somehow tell main that it should exit with a given return code. But that's not always convenient. But check the man page on exit, see if it lets you say exit parentheses 5 or something. All right. So as I suspected, I did not get around to making a Git video last night, but I will do it sometime this week. But what we went through yesterday basically should work. I had a problem in a configuration file, which I have fixed. And I think at that point, if you do everything we did and you do that git push origin master, it should create a repository and upload your code. Yeah.
I have a question about ODP format.
Okay.
What did you mean by a valid double precision number?
Something that scans with %lf. So,
How would you check?
so assuming you're scanning argv bracket 1 because you know it exists. So you said double num. All right, so this scanf says take this string, see if you find a double precision number in it. And if you do, store that value in x. So x is a double. Okay, so scanf will return an integer. We can call it check. So if check is not equal to 1, argv1 is not a valid double precision number. If check is equal to 1, then argv is a valid double precision number. And you know that because what scanf did was it tried to look at the beginning of argv1 and convert it to double precision using that %lf. So scanf actually does that work for you. And it gives you back a code, and if that code's equal to 1, then you got a valid number. Does that make sense? Okay. All right, so let's talk Unix, since this is a course on Unix tools. I'm not going to go into a lot of history of Unix. You can read much better descriptions than I would give you. But Unix has been around since, I think, in the 70s. Started as a commercial product, well, started as an internal project and then a commercial product, AT&T. As Unix, and then Linux came around as an open source version of Unix. And started as a pet project, and grew into what it is today, which is basically ubiquity. Android is basically Unix, right? Unix is pretty much everywhere at this point, because desktop computers are like, less than 0.1% of the CPUs in the world right now, right? 99.9 something percent of all the computing hardware out there is embedded devices. So phones, smart appliances, fitness trackers, things like that. And most operating systems other than Windows are Linux. OS X is Linux. Linux is Linux. So this is a de facto standard almost. And Linux was not developed in a vacuum. It's not like, everybody take your favorite command and put it in this jar and then we'll build an operating system that executes these commands. It was designed with some ideas. One of the ideas being that you could take a small set of commands and put them together to get enhanced functionality. So there's a gazillion commands inside Unix. But if you know 10 or 12 or 20 commands really well, and you know how to put them together, you can do a ridiculous amount of things. Okay, and I know, about this much Linux myself. I've been using Linux for, do I want to do the math? 38 years, so, or Unix originally, for, almost 4 decades, and I know like this tiny little piece of the big picture, because I don't need to know all those other things, and if there's something I need to know, I figure it out, and if I use it a lot, I remember it, and if I don't, I forget it, right? And I think that's sort of the more natural way to learn operating systems, languages, editors, whatever it is that you're doing, is let it be need-based, right? Now for exams, you got to memorize commands for GDB, you got to memorize commands for GDB, but outside of academia, the stuff that you use a lot, you'll remember. And the stuff that you don't remember, you probably don't use a lot. So, so we've talked a little bit about the shell, right? About bash being a program that basically sits here and waits for input. And when you type something in and hit enter, it does something. So what exactly is it doing when you type something in to bash? And remember, this is just a C program. You can write this yourself. You can find the source code for it. It's like, programming assignment 9 million or something. So the basic setup is you type something in, and there's a few things that bash actually understands. Like if I say x equals 12, the program bash understands, okay, that thing on the left is a variable, equals an assignment, 12 is a symbol, so I'm going to set x equal to 12. Okay, it understands that. But there's other things like when I say ls to see what files I have in my directory, that's not part of bash. Okay, there is no ls command built into bash. There's no code in bash.c which says if your input equals ls, then show me a list of files in the directory. Okay, that's not part of the shell. And most of the things that you type in Unix are not part of the shell. They're programs that sit outside of bash. So if I say what is ls, it says ls parentheses 1 list directory contents. Okay, ls parentheses 1 is telling me that this comes from chapter 1 of the manual pages. So there's an online manual for Unix. It's got 8 chapters, usually. Chapter 1 are basically all the Unix commands that we normally type in. ls, cat, move, rm, things like that. And if you say man and you type in the name of a command, like ls, right, there's the manual page, and it's telling me this is ls from chapter 1, right, list directory contents, and lots of information about it. So if I say what is read, that tells me read comes from chapter 2 of the manual pages, and it says this is something to read from a file descriptor. And if I say man read, it shows me the manual page for that. If I wanted to find the manual page for read from a different chapter, right, I could say man read from chapter 3, and if there was a read in chapter 3, it would show me that entry instead. So what is a useful command? So what is? It's a command from chapter 1, and it displays a one-line manual page description. Okay, another useful command is where is. So I can say where is ls, and it shows me all the locations where things related to ls exist. So there's an ls under /bin, and there's an ls under user share man1.
What's the difference between where is and which?
So which is coming next. Let me see if there's a good command for this. So GCC, for example, shows up in 3 different locations: user bin, user lib, and user share man. If I say which GCC, it says if I type the command GCC, which program is going to be executed. That's user bin GCC. And you may have executable programs in different directories, and which will tell you exactly which one's going to be executed. So we got what is, where is, and which. And these are all useful. So which command executes when we say ls /bin/ls? Okay, so what is /bin/ls? We talked a little bit about directory structures, right? So there's a hierarchy of directories and files, starting with what's called the root directory. So that's just /, and there's different files under there. There's bin, there's etc, there's user, there's home, and so on. And then under each of these, there's other directories. So user has a lib, home has a nick, and it has an ezod, and so on. etc has an ssh, and so on. And underneath each of these, there's other directories, and so on. So it's a whole tree, right? And it starts with root of the tree. Get it? Root. All right, so that's how the file system is laid out. And ls is this command inside /bin. So pwd shows you what your current directory is, print working directory. So my current directory is /home/nick/224. So I can change my directory, and if I say cd space /, that changes my directory to be the directory / the root directory. And if I say pwd, it tells me you're sitting under /. So if I say ls, there's everything that's sitting underneath /, and you can see there's bin, right? And there's home, and etc, and there's some other ones in here that I didn't mention. So if we cd into bin, right, I'm sitting under /bin now, and I say what's in there, there's all this stuff inside there. And these are basically a bunch of executable commands, including ls. So ls, you can say ls-l and get more information about a file. So if I do an ls-l on ls, that's the actual ls command. Okay, 129,000 bytes, created October 4th last year, owned by root. And it's just a file. Everything on Unix is a file. That's another piece of Unix philosophy. Everything's a file. Okay. So let me go back to my 224 directory, and let me make a copy of /bin/ls and call it haha. So now in my directory I have a file called haha, and if I say haha, what's it going to do? It's going to do an ls. And if I say haha-l, it's going to do a long directory. I got my own version of ls now, because it's just a file. It's an executable program. And I could hack that file if I wanted. I could, you know, have it print out a goofy name if it sees Nick instead of printing out Nick. Because it's my file now. It's owned by Nick. I can do whatever I want with it. Right? So all this stuff is very open in some ways. But you know, if I wanted to make a goofy version of ls, I can go and I can find the source code for ls.c. I can download that, I can compile it with GCC, and then I can go into the source code and I can make changes there and recompile it and have my own version of ls that does something that I consider to be useful. All right, so this is part of kind of the open mindset behind Linux. Now, if we're on the server, I'm on my local system here. If we were on the server and I tried to change /bin/ls, it would give me a permission error. Okay, on here I think it might actually do it, so I'm not going to do it. But files have permissions, so these first 10 columns on this ls-l, this tells you the permissions for a given file. And we talked about this way back in the beginning when we were executing scripts. But basically, these permission flags look like this: read, write, execute, read, write, execute, read, write, execute. And this is the owner of the file. This is what's called the group. And this is the world, or other. And R is read, W is write, and X is execute. So read, write, execute for owner, group, world. So let's look at HaHa. Its permissions are read, write, execute for the owner. That's Nick. Read and execute for the group, which is also Nick. I'm in my own group. And read and execute for everybody else. So anybody, anywhere on the system can read this file and can run this file. And only I, as the owner, can make changes to it. And so every file has these 9 bits associated with it. Now main2.c is set up to be readable and writable by myself and my group, and readable only by the world. Nobody can execute it. If I try to execute it, we get our familiar permission denied. Now I could change those permissions using that change mode command, chmod, and I could turn on an execute bit, but executing main2.c is meaningless, possibly dangerous. This first column is normally a dash for a regular file, but for something like a directory, it's a D. So that D is saying new project is a directory, tester is a directory, and so on. That doesn't work. But that works. So file is another command you can use to figure out what's going on with a file. So if you say file space in the name of a file, it'll tell you, for example, tester is a directory. If I say file pa2.tgz, it'll say that's a gzipped compressed data. It was pa2.tar, last modified, etc., etc. If I say file main2.c, it tells me that's a C source file and it's ASCII text. If I say file main2, it tells me that's an ELF, that's an executable, 64-bit, blah, blah, blah. If I do file HaHa, that's also an executable. Has a different magic number. So file is a good command if you have a particular file, you want to know what it is, what are you looking at. So what does ls look like, right? We can, or HaHa, right? It's computer speak. It's got the ELF in the beginning to say it's an executable file, but this is all just kind of gibberish. These, these carets followed by @ signs, those are nulls. That's how ASCII code 0 comes out in an editor. But then this other stuff is potentially interesting. And all of this is mostly the binary code that makes ls do what it does. It's the machine code. And there's some text at the bottom. Wherever that was. There we go. Right, because you can say ls space dash dash help and it'll give you a bunch of information about how to use ls. All that stuff is part of the executable file. It's inside a bunch of print statements. So if you have a big executable file and you don't want to VI it and see all the computer speak, another useful command is strings. If you say strings followed by the name of a file, it'll show you the printable strings from that file. It'll dump all of the weird characters and just show you the stuff that might look interesting to a human. And so here's all the strings contained inside the ls program. And there's a fair amount of readable text. So this was all stuff we had to do back in the 80s when you were trying to hack stuff and you didn't have source code available because the source code was really expensive to buy, and this was all proprietary. And so you have to reverse engineer things, right? And you can do that by digging into executables and taking them apart like this. And no matter how hard someone tries to lock down their program, if you've got the executable, you've basically got everything, right? Unless it's doing some kind of on-the-fly decryption. It's like everything that the program does is inside that one file. You just got to figure out like what it's doing. So those are fun exercises. All right, let's get rid of haha. So manual page, right? Synopsis of, so name of the command, synopsis showing basically what the usage is, short description, and then a big long list of arguments, basically switches, things that you can use to modify the behavior. So ls-a says do not ignore those hidden files that start with a period. ls-big A is almost all show things that are hidden but don't show the dot and dot dot, which we'll talk about later, and so on. So there's the -l, use a long listing format, and so on and so forth. And most commands have a number of switches available, things you can put after the command to modify the behavior. For example, ls-l. And there's a convention, there's a lot of conventions in Unix. And these exist only because we've agreed that these are going to be conventions. So for example, if you have a file that begins with a period, by default ls doesn't list it. There's nothing special about a file that begins with a period in its name. To Unix, it's just another file. But the people who wrote the ls program agreed that if you just said ls, we're not going to list these files that begin with a period. So they're hidden files. But that's not because bash has an internal concept of hidden files or Unix knows about hidden files. It's just what ls does, right? So another convention is when you have a command, you can say, you know, a switch like -l or -g or -a. And you can also usually put those together with a single dash and list all of the switches that you want to have instead of saying -l space -g space. But some of these commands want switches like help. And so if you have a switch which is actually a word, it gets 2 dashes in front of it. Otherwise, you might take command -help to mean command -h, -e, -l, -p. So we have sort of 2 ways that we can specify switches. And you'll see those in the manual pages. Some of these take a single dash, but these things that are actual words take 2 dashes in front. So that's something you'll see. And most commands have a --help option, which will give you some sort of synopsis of how to use it. Most commands have a --, version, which tells you what the version is of the command you're executing. And then the manual pages usually end with the author, information on how to report bugs, copyright, and the last section is usually a C also. And if there's related commands, it'll list those in here, and you can start following a chain of commands. Man pages, you got to use Q to quit. Control C doesn't get you out. All right, if questions come up, just like shout them out. Yeah.
Where does man get the page from?
Oh, good question. So you can do a man on man, and I think it will tell you, but if not, I will tell you. So there's usually a section at the bottom for files. So user share man. And we also got that from doing a where is. So let's look at that. So user share man is the root of the manual page hierarchy. And if we look in here, there's man 1, 2, 3, 4, 5, 6, 7, 8. There's the 8 chapters of the manual pages. And if we go into man 1, there should be an entry here for every command inside manual section 1. So up here should be ls.1.gz. So let's copy that. So now I'm in my directory again, and I made a copy of ls.1.gz. And that's even more gobbledygook because it's compressed. So how do we unzip that? G-unzip. And that leaves me with an ls.1. And if I look at that, it says, do not modify this file, which of course we're going to ignore. So this is the manual page. And it's got the parts and pieces that we see when we say man ls, but it doesn't look exactly like it, right? So this is a markup language. .th, .sh, .b, .pp. These are instructions to a text processor that say how should we format this to create a pretty looking page. So pp is, I think, a paragraph, b is a boldface, and I used to actually write in this language, but it's been way too long. But this is a markup language. It's like HTML, right? It's got embedded information that says how this should be formatted. But we can run this command called nroff, which is a text processor. We can say use the macro package an, which is for manual pages. We can feed it this input file and see what the output is.
What happens if you try to unzip a file that you already unzipped?
I think it will say it's not a zip. Yeah, so it doesn't even know what it is. If I renamed it to a gzip, I think it'll say it's corrupted. Yeah, it's not a gzip. It knows. So we can run off this page, and it looks like the manual page, right? But we can change that. So I'll change my ls command to destroy all monsters. And so now that's what my manual page looks like. So there's nothing magic going on here, right? That's the punchline. There's very little to Unix that's actually like built in some critical way to like the core of Unix. Okay, it's really just a bunch of files and a bunch of commands all put together in ways that make it look like this is, an operating system. But it's really just commands and files. And so you can change manual pages, and you can rename commands, and you can make new commands and all of this kind of stuff. And you can do it to do silly things, or you can do it to do not so silly things, right? And this is part of the fun if you have your own Unix set up, right? Like on your laptop or something, you can do a lot more than you can do on the server, but you can still do a lot even on the server, because you can make your own copy of things. All right, so some more details. So directory hierarchy, right? So I'm inside a directory called 224 underneath that nic folder. And there's directories underneath here. There's a directory named tester. There's a directory named new project. I can make a new directory. So mkdir is the make directory command. And I'll just call this my new directory. And now if I do an ls, there's my new directory. And I can change into that by saying cd my new dir. And there's nothing in there right now. But I can make a file. And there's my file. And there's my directory. All right, so there's two special files in every directory. One is called dot and one is called dot dot. And you can see these if you do an ls-a. They're always the first two listed. So dot is just an abbreviation for my current directory. Dot dot is an abbreviation for my parent. Okay, so if I say, here's my current directory, if I say cd dot dot, I've moved up one level, I'm in 224. If I say cd dot dot, I've moved up another level, I'm under home nic. If I say cd dot dot, I'm under /home. If I say cd dot dot, I'm under /. If I do this once more, I stay under /, because / is the root of the whole tree. So if you try to move above that, it just leaves you where you are. It kind of points to itself. If you say just cd, by the way, you end up in your home directory. And if you say cd tilde username, you end up in their home directory. Oh, I'm not on the server. But if you say cd tilde username, it puts you in their directory. Now, if you try to go into somebody else's directory, you'll get a permission error if you try to do anything. But I think you can cd into there, but you can't ls. All right. Is this largely review? Some new stuff? Okay.
What does the single dot do?
Single dot is your current directory. And we use that mostly. Sometimes we do this in 121, right? And we're saying, okay, go into my current directory, find a file named a.out. Okay, but this is where I want to start off tomorrow, is basically when you type a command, if it doesn't know what that command is, like cd, for example, how does it figure out what to execute? Okay, and that's going to take us into environment variables and paths. So we'll start with that tomorrow.